We can also talk about aromaticity when it respects heterocycles. So a heterocycle is just a cyclic structure that has an atom besides carbon and hydrogen in it. So the nitrogens and the oxygens make these heterocycles. Lots of heterocycles are well known and have just common names. This is pyridine, this is pyrrole, this is furan. And as you've seen a little bit already, it's really, really uncommon to see a drug or even a drug-like compound that doesn't have some kind of heterocycle in it somewhere. Your heterocycles are in your DNA base pairs. They're in some of your amino acids. They're pretty much all over. Are these heterocycles aromatic, right? Are they especially stable? And I should say aromaticity is kind of a spectrum thing, right? So it turns out that the stability that pyridine gets turns out to be worth more than the stability that furan gets, for instance. But all of these are aromatic. So for pyridine, we've got 2, 4, 6 pi electrons. For pyrrole, if we count the lone pairs, we count the lone pair on nitrogen, we've got 2, 4, 6. And here in furan, if we count one of the lone pairs, we've got 2, 4, 6. So all of these are aromatic. All of them are surprisingly stable. Now, I just went way fast over some pretty tricky things. So let's back up. How come I didn't mention this lone pair, but I called attention to that lone pair, right? Why do I not count this one when I count 2, 4, 6, but here I do count this one when I count 2, 4, 6? Okay. Well, part of it is because of what orbital the electrons are in, right? So go back to hybridization. What kind of orbital are these lone pairs in? So here are a rough sketch of the orbitals. So this nitrogen already has a pi bond to that carbon. So that p orbital is already taken up in that pi bond. So this lone pair is sticking out. This is an sp2 orbital. It's not conjugated. Okay? So that lone pair is not part of the pi system, so we're not going to count it when we're counting up our 2, 4, 6 electrons. But here in pyrrole, that hydrogen is in the plane. That lone pair is in a p orbital and overlapping all the other electrons. So that kind of means that this nitrogen is sp2, right? Even though it's kind of connected to 4 things, and Chem 250, we might have said, isn't this sp3? Well, it could be sp3 if it wanted to be, but if it distorts to be planar like this, it gets to have conjugation, and conjugation is good. It's stabilizing. And so it will naturally find this planar shape, and that lone pair will be conjugated with those lone pairs. What about furan? Furan's got 2 lone pairs. Should I count both of them? Should I count neither of them? Well, again, think spatially. Think what these things look like, right? In oxygen, I'm going to have, again, it's going to be sp2 hybridized. One of these lone pairs is going to be able to overlap and be conjugated to those pi bonds, but the other lone pair isn't, right? The other lone pair is going to be shoved into that sp2 orbital sticking out. Okay, so essentially, we're going to count lone pairs if they are conjugated to the pi bonds, and especially if it makes it aromatic. But if the lone pair is sort of sticking out like this, or if our heteroatom is already involved in a pi bond, then no, we're not going to count it. It turns out that pyridine is a much better base than pyrrole. If we look at the pKa's of the conjugate acids, the conjugate acid for pyridine is about 5 orders of magnitude a weaker acid than the conjugate acid of pyrrole. This is a much better base. Aromaticity helps explain this, right? So we just said that both of these things are aromatic, okay? If I look here, is this cation still aromatic? The answer is yes, right? It's still planar. I still have 6 fully conjugated electrons like this. So this is still aromatic. However, this is not, right? Because now this nitrogen has to be sp3. It's not fully conjugated. I can't push these electrons into this nitrogen with four single bonds, okay? So this is no longer aromatic. I lost aromaticity to take that extra proton. And so that explains why among amines, pyrrole is a terrible base. Right? Most amines are actually pretty good bases. Pyridine's on the less basic end of those. But pyrrole is a terrible base because for pyrrole to be a base, it needs to give up its aromaticity.